Welcome to the ANOVA tutorial for the Pulse Lab. So we're going to be running a one-way ANOVA utilizing the data from the pulse oximetry lab. Specifically, what we're going to try and compare are the normal readings, the finger pinch reading, and then the improvised reading. Now, one reminder for the one-way ANOVA, you should already be aware of the one-way ANOVA, but a reminder for the one-way ANOVA is when we're comparing one factor that has multiple levels. And what that means is that you have the readings that have three different categories or group. You have a normal reading, you have a finger pinch reading, and then you have an improvised reading. We're also going to go through the box plot generation tutorial and the Tukey's significant difference, which are very useful tests for this kind of data or any data that you have multiple groups that you're trying to evaluate. The first thing that we need to do, because neither of these four columns are going to be filled out for your experiments, you would have collected the test device or the max data, and then the commercial device readings. This data is generated just so you're aware, so the results may vary. Your results might look different, might look similar, so don't use this video as an expectation for what you should get. How we're going to calculate the error rate is that we're going to go ahead and divide the commercial or subtract the commercial from the test device, and that is going to give us what the error rate is. Now, you'll notice that in some cases it's positive, in some cases it's negative. So you will utilize that to determine whether there is a difference between either of these different readings. As an additional thing, because you will need to calculate this later for your post lab, is the bias is going to be the average of this error rate. The precision or standard deviation is going to be the standard deviation of this error rate. And the root mean square is going to be the average squared, the square root of the average squared. So make sure that you run that calculation. Although actually, I think this RMS has to be squared of everything because it's the average of the square of everything. So I think this equation might not be quite right. Double check your readings, but I might have not done that one right. But once you have the error, that's the only one that we really care about. What you're going to do is you're going to create a new sheet with the error rate. So let's say this is my error rate. I'm just going to copy it if Excel lets me here. Whoop, I need to copy it as a value. And then for the condition, in this case, I'm going to call it condition 1. And this is because SPSS doesn't like to use words as categorical variables. It gets kind of finicky when it does that. So we have our first condition, then you're going to go over here. And there's a reason why I use Excel first, is because it's easier to manipulate rather than doing this work in SPSS. But if you feel comfortable doing this work in SPSS, don't let me stop you. The third experimental condition, and if you're a shortcut fan, I'm using the Control Shift V for paste values or paste plain text. Now I am using the web version of Excel, so that is why it's working. If you try this on the regular version of Excel, it might not work. But once we have these conditions, we have the conditions 12 instances of condition 1, 12 instances of condition 2, and 12 instances of condition 3. I'm ready to copy and paste to SPSS. So I'm going to go ahead and do that. I'm going to open SPSS here, right click the first cell, paste with variable names, and then I have my conditions, and then I have my error rates. So the first thing that I'm going to ask you to do is to build a box plot. The little click thing that I did is that my conditions were not set as categorical variables. They were set as metric variables. So for the box plot, you're going to need metric variables. So what we're going to do is we're going to go ahead and select a simple box plot. The conditions are going to be my x-axis because I'm going to have 3 conditions and I want to see the variability of that error rate based on these 3 conditions. And For the y-axis, what I'm going to have is the error rate. And I'm going to hit plot, and then I have here my error rate. And in this case, you can see that the variability for each of them tends towards 0. Some of them are not quite centered on 0. Whereas this condition is centered on 0. This one's a little bit higher, but this one is not quite. You can also see a little bit of their distribution. We are not going to go too deep into the box plots in this class, but it is a useful plot to see just how big the values of a particular measurement work. So you can copy, paste this into the PostLab, and that's pretty much it. Now, going to the analysis of the one-way ANOVA, we're going to click Analyze, Compare Means, and then one-way ANOVA. So the the factors that we're going to be using are going to be the conditions, and then the error rate are going to be the dependent. The dependent is going to be the error rate, and we're going to click here on this post hoc test and select Tukey. So what Tukey is going to do is, one of the challenges with the one-way ANOVA is that it only tells you that at least one of them is different, and we talked about that in the previous tutorial for the first lab. So that is kind of complicated because I want to know which one of them is different, if any of them are different. So what I do is that after I run the test and there is significance, I can run a Tukey. In this case, I'm just running it on the same try, just because I can. So if I go here on the one-way ANOVA table, I can see that this particular grouping is not significant. So it means that the data was not statistically significant. So I cannot tell the three groups apart. So you're going to take this little table and submit it with your PostLab, and then give me an explanation as to whether it makes sense or not that you found significance. And then this multiple comparison post hoc test, this is the Tukeys. What it's doing, again, is comparing 1 and 2 and seeing, are these two different? And you can see here that the significance, none of them are triggering. And in this particular case, if you prefer this type of table, personally I do, this is just telling you that condition 1, 2, and 3 are all in the same group. So for the PostLab, you're going to do box plot, you're going to do this ANOVA table, and then you're going to do this multiple comparison table, or this Tukey's on a significant difference table. Either of these tell me the same information. In this particular case, this has a significance. This one doesn't quite necessarily have the significance in the same way, but I can see that they're all one group. If you have any questions, don't hesitate to reach out, and I will see you all in class.